Right now, your application lives entirely on your laptop. It works perfectly, but to the rest of the world, it doesn't exist. We are going to take that isolated code and plug it into a globally accessible, automated system. By the end of this, you will have a fully containerized NestJS API running on a secure AWS server, backed by a pipeline that automatically deploys your updates every time you push code. To make this happen, we need three distinct components: Docker to package our stack, an AWS EC2 instance to host, and GitHub Actions to orchestrate updates. Removing yourself from the update process means you never have to SSH into a server at 2 a.m. to fix a broken deployment. Your infrastructure becomes predictable, leaving you free to focus entirely on writing your application logic. Step 1 is packaging the NestJS application using a multi-stage Docker build. This method compiles the TypeScript code in a heavy environment, but only copies the finished JavaScript into the final container, keeping the footprint incredibly light. A Docker Compose file launches the API, Postgres database, and Redis cache, linking them to an internal bridge network. The database and cache sit completely enclosed, invisible to the public internet, leaving only the API exposed to outside requests. Before we touch the cloud, we run a local container validation test. We boot the stack on our machine to verify that all three containers start, connect, and function exactly as written. Because the runtime environment is baked directly into these containers, the application will execute identically on an AWS server as it did locally. Now we set up the host. In the AWS console, we provision an Ubuntu EC2 instance. We select the T2.micro tier because it provides the exact compute memory required for our containers, keeping monthly costs effectively at zero. During setup, AWS prompts you to download a .pem key pair. Save this file to a secure location. If lost, you permanently lose server access. Next, we configure the network security group rules. We open port 22 strictly for our administration access via SSH, and we open ports 80 and 443 to allow incoming HTTP and HTTPS web traffic. With the instance running, AWS assigns it a public IP address. We take that IP and paste it into the DNS settings of our domain registrar, creating a new A record to connect the domain name. That strict security group is the only barrier separating your hardware from the internet. By denying all other ports, the server blocks automated vulnerability scanning. Using that .pem key, we SSH into the raw server environment for the first time. Here, we install the Docker engine and Docker Compose. When external traffic hits the server, a central Nginx proxy node funnels the request into the internal API container. By replacing the placeholder text with our live domain name, the proxy knows exactly where to direct requests. To secure that connection, we execute a certbot script. It verifies our domain ownership and automatically generates the Let's Encrypt SSL certificates, activating HTTPS. By forcing the reverse proxy to handle the complex math of SSL encryption, our internal NestJS API spends 0 CPU cycles decoding traffic. It dedicates 100% of its resources to executing your business logic. To automate updates, our server needs to pull code from GitHub without requiring a password every single time. We solve this using deploy keys, SSH keys that grant a machine read-only access to a specific repository. We generate a new SSH key directly on the EC2 server, print the public half to the terminal, and copy it into our GitHub repository's deploy key settings. We store our server IP, username, and private key securely in the GitHub Secrets interface. This ensures our credentials are never exposed in plain text. Our deployment YAML flowchart triggers when we push code. The first job builds and tests the app, halting if it fails to protect the server. Once passed, the second job logs in securely, pulls the code, and restarts the containers. A simple git push now initiates a rigorous, isolated testing phase, followed by a hands-off infrastructure update, entirely eliminating human error from the deployment cycle. Let's prove the architecture. Back on our local machine, we modify a visible response string in the API codebase, save the file, and commit the change to the main branch. The moment the code hits GitHub, the pipeline wakes up. It compiles the new TypeScript, connects to the AWS server, and cleanly cycles the Docker containers to load the new instructions. We refresh our browser at the live domain name. The newly updated API response appears instantly on screen, sitting securely behind a verified SSL padlock. Setting up this enterprise-grade architecture requires upfront effort, but it permanently decouples code creation from the friction of server management. From this point forward, if you can write the code, you can ship it to the world.
Enhance your coding skills with us. Don't forget to subscribe to Code 5 Food for the latest updates and tutorials.